Welcome to The Explainer. Today, we are pulling back the curtain on the invisible architecture that honestly runs our entire digital world, databases. We're going to dive into how they take this overwhelming mess of information and turn it into something crystal clear and actually useful.
So, here's the plan. First, we're going to face the chaos head-on. Then, we'll put on our architect hats to design a real solution. After that, we'll connect the dots, become data detectives, and finally, unlock the powerful answers that are hidden deep inside. All right, let's kick things off by looking at a problem I think we've all felt: the sheer chaos of messy, disorganized information. You know that feeling, right? When you're trying to find just one specific thing, one email, maybe one customer's phone number, in this huge disorganized pile of data? It's that feeling of being completely buried, knowing the answer is in there somewhere, but you have no idea how to find it. It's maddening. And in the real world, this chaos usually looks something like this. Just a jumbled spreadsheet. I mean, look at this. You've got Sue Grader and then just Sue. You've got Barb Shank listed more than once. The information is all over the place. Now, imagine trying to get a clean list of your customers from this. It's a total nightmare. So, how do we fix this mess? Well, the answer isn't to just keep piling on more data. The key is to stop and start thinking like an architect, to actually design a solid blueprint for our information. And that brings us right to our second section, the architect's blueprint. Okay, so the absolute foundation of this whole structure is the table. You can think of it like a spreadsheet, but, and this is a big but, it has very strict rules. Each row is a unique record, like one single customer. And each column is a field that holds one very specific piece of information, like just their first name or just their city. And this, right here, this is the secret sauce to good database design. It's not about just typing stuff in, it's about thinking backwards. You actually start by figuring out what answers you want to get out. Then you break your data into the smallest possible pieces, give everything a unique ID, and plan how it's all going to connect.
And this smallest parts rule, this is probably the first big aha moment for a lot of people. See, if you lump a whole address into one big field, you can never ask a simple question like, hey, show me all my customers in California. By separating out the city, the state, and the zip code right from the start, you're not just organizing your data for today, you're future-proofing it. You're giving yourself the power to ask questions you don't even know you have yet.
Now, to make this whole structure totally foolproof, every single table needs one critical thing: a primary key. This is just a field that has a unique identifier for every record. Think of it like a social security number or a student ID. It's a guarantee that no two records can ever be confused for each other. It completely solves that duplicate data problem we saw in that first messy list. Okay, so individual tables are a great start, but the real magic, the real power, is unleashed when we start connecting them together. And that's our next step, connecting the data dots. So, when we're building our tables, we can't just throw information in willy-nilly. We have to assign a data type to every single field. This basically tells the database what kind of information to expect. Is it text? Is it a number you can do math with? Is it a date? This forces everything to be consistent, and trust me, it prevents so many errors, like someone trying to type the word 12 in a field that's meant for the number 12.
Okay, now here's where things get really clever. How do we link a table of our customers to a totally separate table of their orders? Well, we use something called a foreign key. You literally just take the primary key from the customer table, that unique customer ID, and you drop a copy of it into the orders table. It acts like a breadcrumb, creating this perfect, unbreakable link between a specific customer and all of their orders.
And this whole idea leads us to the most common and honestly the most powerful type of relationship there is, the one-to-many. Just think about it. One customer can have many orders. This structure is so incredibly efficient. You only have to store the customer's name and address one time, but you can link it to a basically unlimited number of other things, like all the purchases they've made over the years. So, our architecture is now clean, it's efficient, and it's powerful. It's time to switch roles. Architect hat off, detective trench coat on. It's time to find the clues that are hidden in our data. This is it. This is the moment we've been working for. We've built this perfectly organized library of information, with every single fact in its proper place. So now, as the detective, we get to decide which leads to follow, which questions to ask. We finally have the power to interrogate our data. And the way we do that is with a tool called a query. And this brings us to Section 5, Unlocking Answers, which is where all that careful architectural work finally pays off in a huge way.
So what is a query? It's really simple. It's just a question you ask your database. But unlike asking a person, it's a question with incredible precision. It's a tool that lets you sift through maybe millions of records and pull out only the exact little slice of data that you're looking for. Think of it like this. A query is like a search warrant for your data. You tell it which table to look in this case, customers, and then you give it a clue. Under criteria for the first name field, we're basically telling the database, go find me everyone whose first name is exactly Harry. And just like that, the database becomes your own personal research assistant. It scans every single record in that customer's table and comes back with a brand new, temporary table that contains only the records that perfectly match your clue. In this case, every customer named Harry, along with their last name and their city. All that chaos is gone, and it's replaced with one precise answer.
And the questions you can ask can get incredibly specific. You can say, find all the sales that are greater than $5,000. You can use a wildcard to find every last name that starts with Smin. Or you can combine criteria. Show me all the customers from California and who bought something in the last 30 days. The possibilities are pretty much endless.
And this is where it all comes together. Those relationships we built earlier with the foreign keys, they are the absolute key to unlocking these powerful questions. Because we linked our customers to their orders, a single query can now pull a person's name from one table and an order total from a completely different table, and it does it seamlessly. This is how you find insights that were totally invisible in that original messy spreadsheet.
And that really brings us to the big takeaway. Structuring data isn't just some technical skill, it's a powerful way of thinking. It's the ability to look at any complex system, break it down into its smallest parts, and then ask the right questions to reveal the truth that's hidden inside. So now that you have the blueprint, what chaos in your world are you ready to bring some clarity to?